All right, Math 8. So the second type of transformation, as we talked about, is a reflection. Okay, now I'm not going to talk about the intro stuff too much. Okay, but remember that these are always going to be congruent. Okay, because reflection does not change the size of anything. Okay, if you went up to a mirror and you put your hand on the mirror, the hand in the mirror, and your hand would be the exact same size. Okay, so this is a reflection. Now, you might not know that. It almost looks like it could be something else, but we definitely know that this figure, triangle ABC, did not just slide over, okay? It did not translate to the right, okay? It clearly did something else. Now, sometimes it might look like a rotation, but this is why we put the points on there. So in this case, if I was going from A to A prime and it's a reflection, we know that it would be right here, okay? B prime would be over here, and C prime would be here, okay? And it looks like it just kind of flipped over. Now, it's important to know where your points are labeled, or else you're not going to know what type of transformation occurred. So you will have to name what happened sometimes. Other times you might have to actually do it. By doing it, you probably have a better understanding of what happened, okay? So in this case, you can see that the triangle flipped over something. Now, I'm kind of showing you something here, but someone might notice that, well, it doesn't, like, what does it flip over, okay? There's going to be some sort of line it flips over. Now, it could be an imaginary line, like so, that it's actually flipped over, that you're not going to have to worry about, okay? It will tell you what it's flipping over, or you will have to name it. So in this case, if it looks like you don't know what it flipped over because it's something imaginary, that means you probably messed up, okay? In reality, what is actually happening here, oh, I moved my graph, I didn't mean to move my graph, okay? What is actually happening is this triangle is actually right here, okay? And then my points are there. Now, you should be able to tell what it reflected over, okay? Even like move that lower. Okay, if you couldn't tell, it looks like it's reflecting over the y-axis. Remember, this is the y-axis, this is the x-axis. Okay, so if you were to answer, hey, what happened? You would say it reflects over, or you could say the word across, okay, over the y-axis. Okay, but it's important to know that where the points are at, okay, and then realize it flipped over. You can see that it flipped over. Okay, so we're going to do a full example together with a couple little statements. So if you need to pause this and you want to kind of copy this down, you can. Otherwise, we're going to do an example, and then after that example, we're going to do the rest together in class. So here we go. A reflection flips an image. Over a line. Okay. Now, it is best done. Actually, I have my tablet working. Why am I not using that? Okay. It is best done by counting the distance. Okay. The reason it's best done by this is because if something is flipped over a line, that means it needs to be the same distance away from the line on both sides. Okay. If, again, if like you're reaching towards the mirror, your hand's a foot away, well, in the reflection in the mirror, it looks like your hand's a foot away. Okay. It's the same distance. So your hand doesn't touch the glass in the reflection until you physically touch the glass in real life. Okay. So counting the distance is the easiest way. So in example 1, we're going to do basically what we just did in the previous problem. We're going to reflect over the y-axis, okay? So we do this by counting how far, okay, again, this is the y-axis, counting how far the points are away, and then we just move it over the same distance, okay? So if we look at point A is 2 to the right of the y-axis, so therefore it needs to go 2 to the left. I'd plot a point, and I'll label it A prime. Okay, always label it A prime and stuff like that. I know yesterday we talked about like a DEF. You only need to label it DEF if it's telling you to do that or something's listed like that. In this case, there's nothing there, so label it A prime. B prime is 1, 2, 3, 4 to the right, so we would go 1, 2, 3, 4 to the left. And then C is 1 to the right, so we would go 1 to the left and label it C prime. Okay, and then we draw our triangle. My triangle is going to be terrible. Actually, go back to the mouse for this. If I can find my mouse. Make it a little bit better triangle here. Okay, so you can see after we reflect, we have the same triangle, just flipped over the y-axis. Okay, problem solved. Now, one thing you're not going to have to know too much, but I'm just going to show it to you now. If we were to look at point A, okay, point A, my x value is 2 because we went right 2, and my y value is 5, so it's 2, 5. And just look what changes when we go to A prime. Okay, it will be like this every time you flip over the y-axis. Well, we went left 1, 2, so therefore it's a -2, and we are up to 5. And you notice what changes when you flip over the x-axis? The x, or the y-axis. So whenever you flip over the y-axis, the x changes from a positive to negative, or from a negative to positive, just depending on the picture. Okay, but it will always be like that, because if you notice A is at the same height, it just moves left and right. So therefore the x is what's changing. Okay, it's just something good to know. You don't technically need to know that for the level 2 test, but it is good to know because it will just help you in the future. Okay, so you are going to try example 2 on your own. Okay, pause if you need to get this down. Okay, example 2 is right here, reflection over the x-axis. Try it on your own, and then we will go over that and the next example together in class. And I will see you then.